This is a solution video for question 17 of paper 2 from the TMUA 2020 exam. So in this question, we're told we have this set S that has 6 distinct integers in it. And then we're also told that we can divide S into two disjoint sets A and B, and both A and B have 3 elements. We're told information about the mean of A, the mean of B, the median of A, and the median of B. And then we're asked, what is the smallest possible range of S? So in order to do this question, we kind of need to think of what are the possibilities that the elements of A can have, and what are the possibilities that the element of B can have. So let's try and think about set A first. So if I let the first element of A be little a, and the last element of A be little b, because the median is 8, I know that B is the largest element, so it's going to be bigger than 8, and A, the smallest element, will be smaller or equal to 8. So if we now look at the information about the mean, that means if I calculate the mean of those 3 things, that should be equal to 10. So A plus B plus 8 over 3 must be equal to 10. So if I cross multiply, I get A plus B plus 8 equals to 30. So A plus B is actually 22. Now, since we're told that we have that all elements are distinct integers, that means A cannot be equal to 8. And A cannot be bigger than 8 either, because A here is labeled as the smallest element. So A can take values from 7 to 6, 5, 4, 3, and so on. And the corresponding values of B will be 15, 16, 17, 18, 19, and so on. If we do the same thing for set B now, where C will be the smallest element of B and D the largest element of B, then the mean of C, 9, and D will be C plus 9 plus D over 3, and that's equal to 12. That's what we're given here. So C plus D then is going to be 36 minus 9, which would be 27. So again, if we look at the possibilities that C can take, then we know that C cannot take the value 8 because 8 is already in A. And C cannot take the value 9 because 9 is already in B. And we're told we have 6 distinct integers. So that means C can take value 7, 6, 5, 4, 3, and so on. These are the corresponding values of D. So now we're trying to think about the smallest possible range of S. So the range is just going to be D minus A, the largest element of B minus the largest element of A. So given this is the range, then we'll need to make this range as small as possible. That means we want A to be as big as possible and D to be as small as possible. So we want to take D from one of these values up here and A from one of these values up here. So if we try out some values, so we take, for example, a large value of A, let's take the value A equals 6. So if we take A equals 6 and D equals 20, then C will be 7. And I can't take A to be 7 to reduce the range because, remember, A and C must be distinct. So that means the value 6 and 20 gives us a range of 14. Similarly, if I try to make A larger instead, so I make A a little bit larger, I go 8 to 7 from 6, then I go with D equals 21 here, and C equals 6, and I get, again, a range of 14. So now if I pick any other value of D, for example, if I take any other value of D, then it's going to be bigger than 21 over 21 or 22, and than 20 or 21, sorry. So no matter what number I'm going to pick here, I'm going to get a range that's bigger than 14. So that means that our answer is just E14.